Good morning, everyone. In our last session, we talked about the foundational principles of market dynamics. Well, today, we're going to take those principles and apply them to a truly critical business challenge, pricing strategy. We're actually going to build a mathematical model from the ground up, one that will give you the power to answer a question that can make or break a new product launch.
Just think about a company launching a brand new smartphone. If they slap a $1,500 price tag on it, sure, it might scream premium product, but you risk shutting out a huge part of your potential market. On the other hand, what if they price it at, say, $500? You might sell a ton of them, but are you leaving a huge pile of cash on the table? This is precisely where just guessing, where your intuition fails you, and it's why we have to turn to a more rigorous, a more analytical approach.
So, here's our roadmap for today. We're going to start by really digging into this pricing puzzle. Then we'll translate actual customer behavior into a mathematical model. From there, we'll build out the total revenue equation, figure out how to find that absolute peak revenue point, and finally, bring it all together to make a strategic, data-informed decision. All right, let's dive in. As future business leaders, one of your main goals is often going to be optimizing revenue. And the starting point for that entire process, the absolute bedrock of this analysis, is having a deep, deep understanding of the consumer.
You see, this relationship between the price of a product and the quantity people are willing to buy, well, that's the cornerstone of everything we're doing today. And I want to be clear, this isn't just some abstract idea from an economics textbook. It's a real, quantifiable model of human behavior. Mastering this dynamic is absolutely essential for every single pricing decision you're going to make in your careers.
So the big question is, how do we take this complex consumer behavior and translate it into a mathematical framework we can actually work with? Well, we do that by creating what's known as a demand function. Think of it as an equation that perfectly captures that relationship between the price of a product and how many units people are willing to buy at that price. This demand function becomes our predictive tool. Now, it's not a crystal ball, right? It can't see the future. What it is, though, is a model that we build using real data, from market research, from consumer surveys, from past sales figures. It allows us to forecast with a pretty high degree of certainty how the market is going to react to different prices we might set. So let's look at a concrete example that could come from that kind of analysis. Okay, I want you to look very closely at this equation. P here stands for the price per unit, and X represents the quantity we sell. Now, that negative sign in front of the X is incredibly important. It's the mathematical representation of that inverse relationship we've been talking about. As X, the number of units we want to sell, goes up, the price P has to come down. This is a fundamental concept in economics, and for those of you who've taken microeconomics, you'll recognize this is closely tied to the price elasticity of demand. So, understanding demand is a critical first step, but it's not the end goal. A business's success isn't measured in how much demand there is, it's measured in revenue. So, our ultimate goal here is to use what we know about the market to maximize our total income. Let's now build the equation for total revenue. Now, this formula for total revenue is a cornerstone of business math. Revenue equals price times quantity. Seems simple, right? But its true power is only unlocked when we combine it, when we integrate it with our specific demand function. That's when we create a powerful custom model that truly reflects the dynamics of our specific market. Okay, let's walk through this derivation very carefully, because this is a common place where students make errors. We start with our basic revenue formula. R of X equals P times X. Simple enough. Now for step 2, we substitute that entire expression for P from our demand function. Here's the common mistake. People sometimes forget to multiply the entire expression by X. You have to make sure you do that. By carefully distributing that X across the numerator, we get our final revenue function, which, as you can see, is now only a function of one variable, the quantity sold, X. Now let's take a hard look at the revenue function we just created. The key feature here is that X squared term, specifically the fact that it's a negative X squared term. This tells us that we're dealing with a quadratic function. And if you remember from your algebra courses, you'll know that the graph of a quadratic function is a parabola. This geometric insight is the key that's going to unlock our whole problem. I want you to actually visualize the graph of this function. As we start selling more units, moving from left to right along the x-axis, our revenue starts to climb. But to keep selling more and more, we have to keep lowering the price. Eventually, we hit a point of diminishing returns, a peak. After that peak, any further price cuts actually cause our total revenue to go down. Our job then is to find the exact quantity where that peak occurs. And here's the really cool part. Our complex business problem has now been transformed into a very clear, well-defined mathematical problem.
We just have to find the vertex of this parabola. The x-coordinate of that vertex is going to be the optimal number of units to sell, and the y-coordinate will be the maximum revenue we can achieve. So, how do we find that vertex? Thankfully, we have a formula for it. But first, let's rewrite our revenue function to match that standard quadratic form you see on the screen. If we rewrite it, r of x becomes negative 1/50 times x squared plus 1500 divided by 50 times x. By writing it this way, we can clearly see our a and b coefficients. A is the number in front of x squared, so it's negative 1/50, and b is the number in front of x, which simplifies down to 30. Now we have everything we need to calculate the optimal quantity. We've now arrived at the culmination of our analysis. This is where we translate all of our maths into a real, actionable business strategy. We have our formula, we have our coefficients, all that's left is to plug in the values and interpret the answer.
So we plug our values into the vertex formula. We get x equals negative 30, divided by 2 times negative 1/50. When you do the math, this reveals that the optimal quantity, x, is 750. Now, this isn't just a number from a formula. This is a strategic insight. It's the precise number of units we need to sell to generate the absolute maximum possible revenue for our product.
Okay, I really need to emphasize this next step because this is another place where students frequently get confused. The vertex formula gave us the optimal quantity, but it did not give us the optimal price. To figure out the right price to charge, we have to take that optimal quantity, 750, and plug it back into our original demand function, which, if you recall, is the equation that defines the relationship between price and quantity.
And when we perform that calculation, 1500 minus 750, and then divide that result by 50, we get a price of $15. This is our optimal price point. At this exact price, our model predicts that we can expect to sell exactly 750 units, and in doing so, achieve our maximum possible revenue. So, this table really sums up everything we found. By producing and selling exactly 750 units at a price of $15 each, the company will hit its maximum potential revenue of $11,250. Now, it's crucial to remember that this is a simplified model. In the real world, of course, you'd also have to factor in things like your production costs, your marketing budget, what your competitors are doing, and so on.
As you move forward in your careers, you are going to find yourselves in boardrooms where you have to defend your decisions. And when you're asked to justify a pricing strategy, you won't have to rely on a gut feeling. Instead, you'll be able to present a data-driven mathematical model that shows precisely why a price of $15 will maximize revenue at $11,250 and how any other price, higher or lower, will lead to a worse outcome. That is the strategic advantage that business mathematics gives you.
The main thing I want you to take away from our lecture today is this. We are not just learning how to solve equations. We are learning a systematic framework for making smart, defensible, and ultimately profitable business decisions. This is the kind of analytical thinking that modern business strategy is built on. I really encourage all of you to master these concepts because they will serve you incredibly well throughout your careers.
Now, as you prepare for our next session, I want you to think about the question on the screen. We've just figured out how to maximize revenue. But what about profit? Profit, as we all know, is revenue minus costs. So in our next lecture, we're going to build on this model and explore how to incorporate costs so we can maximize not just our top-line revenue, but our bottom-line profitability. Thank you for your attention.